Let us see the unit 3 complete circuit, complete chapter in one. The unit 3 in network analysis is steady state analysis. Steady state analysis of AC circuits. In AC circuits, AC power will be used. AC power means alternating current. Alternating current will connect it to a circuit. This alternating current has frequency and magnitude both. From that AC circuits, impedance will come to the picture. Z. In DC circuits, R will be there, whereas in AC circuits, Z will come to the picture. Z is impedance. What is the unit of impedance? Ohm. Impedance is the property of a coil or winding or inductor. The current flowing through it, it will oppose. That means impedance is similar to resistance, it opposes. The impedance is given by Z equal to R plus JXL. Z equal to R plus JXL, that we have to remember. Z equal to R plus JXL, whereas XL is known as inductive reactance, R is known as resistance. Suppose a coil having inductance L means we have to calculate XL. XL equal to 2 pi FL. Every inductor stores the energy. Due to that energy, it will oppose that current. Whenever current flowing through this current will be opposed by the inductor. That property of coil is called as impedance. Z equal to R plus JXL. R plus JXL. R is the internal resistance of this coil. Sometimes internal resistance may be represented as like this. R and L are connected in series, in the sense R is the internal resistance of this inductor L. R plus JXL, complex form of resistance and inductive reactance, is called as impedance. XL equal to 2 pi FL. This formula you have to remember. XL is nothing but 2 pi FL. Now the magnitude of impedance is square root of R square plus XL square. Since J square equal to 1, you will get square root of R square plus XL square. From that, theta equal to tan inverse XL by R. From this equation, theta, if you apply theta for this, Z equal to, suppose it is a triangle, right angle triangle, it is Z, it is R, it is XL. If you apply theta, it is the theta or phi, phase angle. For impedance, what is the angle? That is called phase angle. Z at an angle of theta, this is called phase angle. For this angle, you can apply cos, then you will get power factor. Next is the impedance, also defined as the ratio of voltage to current. The ratio of voltage to current. If you know the voltage and current, then you can calculate impedance Z. The unit of impedance is ohm. Ohm's law for AC circuit, that is temperature remaining constant, current flowing through conductor is proportional to the voltage and inversely proportional to the impedance. When impedance increases, current will decrease. V equal to IZ is called Ohm's law. Next, impedance triangle, you can see impedance triangle is represented by the right angle triangle. The hypotenuse is impedance and R is the adjacent side, opposite side is XL, and this is called theta or phi, this is called phase angle. RL AC circuits, if you see, you can understand. RL AC circuit means R and L is connected in series. Suppose consider the resistor and inductor are connected in series, connected to a AC voltage source V equal to V max sin omega t. It is the equation of AC voltage. V equal to instantaneous voltage, V equal to V max sin omega t. VL is the voltage across inductor, VR is the voltage across resistor, V is the applied voltage. From that V equal to IZ, you can write I into R plus JXL. When current enters to the resistor, it is in phase with voltage. We assume that V is the one voltage phasor or voltage vector. The current flowing through resistor is IR or I will be in phase. This current flowing through a resistor will be in phase. That means theta equal to 0. Now it is the V, I, then the angle is 0. There is no phase displacement between voltage and current. Phase displacement in phase angle theta equal to 0. That is for resistor, phase angle is theta equal to 0. How it is possible? Because voltage and current are in phase, there is no phase angle. No phase angle means 0 degrees it is. Phase angle theta equal to 0 degrees. This is the phasor diagram for R when current enters to resistor. When current enters to inductor, the current lags the applied voltage by 90 degrees if it is a pure inductor. Pure inductor means 90 degrees. If theta is 90 degrees, if current enter to the same current will enter to the inductor, it lags 90 degrees. You can see here the angle between voltage and current is known as phase angle. Define phase angle, 2 marks question will come. The angle between voltage and current is called as phase angle. Voltage and current angle is theta. Now when current enters to the inductor, it is the voltage applied, V equal to V max sin omega t. It is pi, it is 2 pi, 1 cycle. When current enters to the inductor, it lags by 90 degrees. It lags by 90 degrees. This one is current entered to the inductor. I equal to I max sin omega t minus pi by 2. Now we know that V equal to L di by dt. Voltage across inductor is V equal to L di by dt. V equal to 1 by L V dt. Integrating on both sides, di equal to 1 by L. Integral 1 by L V dt. Integrate on both sides, you will get Vm by L minus cos omega t. From that, I equal to I max sin omega t minus 90 degrees. The phasor diagram for RL circuit is this one. The phasor diagram. Let us consider V is the voltage. Now current I lags by an angle phi. The resistance drop will be I into R is in phase with current, and IXL IZ. From this, V equal to IZ you will get. Apply cos for the phasor diagram, then you will get R by Z. Cos phi equal to R by Z also you will get. The power is defined as, now the power factor is defined as the ratio of resistance to impedance. Real power P equal to VI cos phi, reactive power P Q equal to VI sin phi, apparent power equal to S equal to VI. If you know these three formulas, sometimes they will ask 5 marks question, find real power, reactive power, apparent power. These formulas we have to remember. Now a simple problem. An RL circuit consists of resistor 90 ohm, inductance of L equal to 1 Henry are connected in series across 230 volts 50 amps supply. Then find the total current, power factor, power consumed in the circuit. An RLC circuit consists of resistance 90 ohm, inductance 1 Henry are connected in series across 230 ohm. Now draw the circuit first. According to given data, draw the circuit. 90 ohm, 1 Henry, L equal to 1 Henry. It is 90 ohm. It is R, it is L. And supply voltage is 230 volts, 50 hertz. Now inductive reactance we have to calculate. XL equal to omega L or 2 pi FL. 2 pi into F is 50, L is 1 Henry, then 100 pi, that one is 314.28 ohm XL. Inductive reactance. Impedance Z we can calculate. Impedance Z is the formula R, Z equal to R plus JXL. From that, square root of R square plus XL square, you can calculate Z. Now what is the current? Current I equal to V by Z. Ohm's law for AC circuit is V equal to IZ. Then from this I equal to V by Z. Then you can calculate I. Power factor cos phi equal to R by Z. R by Z if you get 0.275, or for this Z, what is the phase angle? If you calculate phase angle or convert this into rectangular form into polar form, you will get Z at an angle of theta. This angle should be same, this angle. Now power consumed is, real power consumed is VI cos phi, V into I into cos phi, cosine of the angle cos phi, this one. Reactive power is sin phi. From the phi we can calculate sin phi. Reactive power is VI sin phi and apparent power is VI. Now draw the phasor diagram. First we consider voltage as a reference. For every solution draw the phasor diagram, then you will get maximum marks. The current I lags at an angle 74. We calculated the power factor is, phase angle cos phi is 74. If you go for inductance and resistance, the power factor is 74. Now this is the resistance drop and reactance drop. This is the impedance drop. Now another problem, a coil of 3 plus J6 ohm connected to an AC supply of 220 volts 50 Hz. Find impedance, current taken by the coil, power factor and real reactive power consumed by the coil. This type of problem we solved for, that is given for previous exam. Previous exam lo kuda same problem icharu. Ante values may be change. Impedance is direct okosari ikkada Z value directly given in the form of polar form also they will give. From that, according to polar form and rectangular form conversions, resistance unit of impedance is resistance. Z equal to R plus JXL 3 plus J6, V is 220 volts, F is 50 Hz is given, XL we calculated, XL equal to 2 pi FL, 2 pi FL, directly they given XL, from that L we can calculate, L equal to 0.19 Henry, Z equal to R plus JXL, Z equal to 6.78 ohm, R plus JXL, current I equal to V by Z, V by 220 by 6.708 you will get. Next, power factor cos phi is R by Z, or directly if you convert this 9 plus J XL, what is XL? XL we calculated 6 ohm, 9 plus J6, if you convert into polar form you will get Z at an angle of theta. This angle should be equal to this one, power factor 63 angle will get. Real power VI cos phi, same formula you substitute it, reactive power VI sin phi. Now draw the phasor diagram. V is taken as a reference, current I is taken lag at an angle 63. Parallel to this IR drop VR, and 90 degrees to this VL, I into XL, V into IZ. If you join this, it is Vs. This phasor diagram you must draw for any problem or theory also. Similarly, series RLC circuit. RLC, R and L when connected we seen previously. In addition to that, C will be added. When C added, what is the impedance? Z equal to R plus JXL minus XC. Z equal to R plus JXL minus XC. We are assuming so many terms in this circuit. What is VR? Voltage across inductor. L is VL. VC is the voltage across capacitor. Next is XL is inductive reactance. XL is 2 pi FL. XC, what is XC? Inductive reactance XL, whereas capacitive reactance is XC. XC equal to 1 by 2 pi FCR, 1 by omega C. Z equal to impedance of the circuit. Z equal to V by I, or Z equal to R plus JXL minus XC. This formula you have to remember, R plus JXL minus XC. It is very important to find impedance of RLC circuit. Previously only L is there, this only consider R plus JXL, minus XC will be considered. When current entered to the resistor, it is in phase. When current entered to the inductor, it is lags by 90 degrees or by an angle phi. If it is a pure inductor, it will lag. Next, when current enters to the capacitor, the current lead by 90 degrees. Current IC will be lead by 90 degrees. The same phasor diagram we are representing. Current, it is the actually V equal to V max sin omega t. Leading in the sense already 90 degrees. It is 0. Prior to this it is there 90 degrees. Ikkada munde start ayi untundi capacitor current. This one is called IC. The complete phasor diagram of RL circuit you can see here. VL minus VC, VL into IXL. This one V equal to IZ. Now RLC circuit derivation it is Z equal to R square plus XL minus XC whole square. This derivation you can see. From the phasor diagram you can find this. How you got this? From the phasor diagram, this is the Z, V equal to IZ. From this VL minus VC you can represent VL minus VC as I into XL minus XC. I you can take outside, then R square plus XL minus XC. From this it is called impedance Z. Z equal to square root of R square plus XL minus XC whole square, or if you remove the proportional, if you remove the square root, Z equal to R square Z equal to R plus JXL minus XC you will get. This formula you have to remember. Z equal to R square plus XL minus XC whole square, that is the magnitude. Whereas Z equal to R plus J into XL minus XC. What is the formula for XL minus XL and XC you must know. Okay, this formula you have to remember for AC circuit. Next is phase angle. Phase angle cos phi. We know that power factor is defined as the quotient of the angle between voltage and current. From that, phase angle is voltage and current. What is the phase angle? That is called angle between voltage and current. What is the angle? That is called phase angle. Phase angle is defined as the angle between the voltage and current vectors is called phase angle. Cosine of that phase angle is called power factor. Remember this. Cosine of the angle between voltage and current is called phase angle. Power factor. From that, if you apply cos for this phase angle, you will get power factor. If XL equal to XC, phi equal to 0. If XL is greater than XC, phi is positive, means lagging it is. Phi also you can calculate from this formula. Tan inverse XL minus XC by R. If XL is less than XC, phi is negative, leading power factor it is. If capacitor ఎక్కువ ఉంటే XC ఎక్కువ ఉంటేనే లీడింగ్, ఎందుకంటే కెపాసిటర్ వాల్యూ ఎక్కువ ఉంటే లీడింగ్ పవర్ ఫ్యాక్టర్ ఉంటుంది. ఎక్కడైతే రెండు ఈక్వల్ అవుతాయో దట్ ఈస్ కాల్డ్ F0. The resistance of 20 ohm and RLC problem also important. RLC series circuit problem you can see here. The same problem I am explaining. A resistance of 20 ohm, inductance of 0.2 and capacitance of 150 microfarad connected in series to 230 volts 50 Hz AC supply. Find impedance, power factor, phase angle, active power, reactive power, apparent power, all this. Supply voltage is given. First write the given data. V equal to 230 volts, F equal to 50 Hz, R equal to 20 ohm, L equal to 0.1 Henry. XL you can calculate from the L, 2 pi FL. First calculate XL. Inductive reactance. Capacitance value is given. Capacitor value 150 microfarad, 150 into 10 power minus 6. XC equal to 1 by 2 pi FC. Substitute all. You will get XC capacitive reactance in ohm, that is 21.2. Draw the circuit or LC and given supply. Impedance Z equal to R plus JXL minus XC also you can use, or magnitude directly you can calculate square root of R square minus R square plus XL minus XC whole square. Then Z you can calculate, substitute all values, then you will get 46.18 ohm. Phi equal to tan inverse XL minus XC by R. Then Z is 46.18 at an angle 64.32. Or directly if you substitute here, Z equal to R plus JXL minus XC without this square, without this square root, Z equal to R plus JXL minus XC. Remove this square, then you can calculate, you will find this. Power factor cos phi equal to R by Z. Formula. Power factor cos phi equal to R by Z. Power factor is lagging because XL is greater than XC. If you observe this, XL is 62, XC is 21.2. That means XL is greater means lagging power factor. Phi equal to how much? You will get R by Z, lagging power factor. Next, active power is VI cos phi or cos theta. VI cos phi. Draw the power triangle. Active power VI cos theta, reactive power VI sin theta, apparent power S equal to VI. If you draw this like this, then you can easily understand. You can easily remember power triangle, impedance triangle. Reactive power Q also you can calculate, VI sin phi. Reactive power will be opposite side. Apparent power S equal to, or complex power S equal to VI. Similarly, we can calculate and draw the phasor diagram. For phasor diagram, you have to remember first current taken as a reference, I into R, V equal to IR. Next, VL minus VC, this one. This angle is theta. VC equal to IXC, VL equal to IXL. If you move this point to this side, VL minus VC will get V equal to IZ. Similarly, another problem, you can solve it. Same problem, draw the phasor diagram. Super node and super mesh. That also will come for supernode and supermesh. What defines supernode? Defines supermesh for AC circuits. A supernode exists when an ideal voltage source is connected between two nodes. Between two nodes, when an ideal voltage source is connected, it is called supernode. Supermesh means between two meshes, a current source will appear. That is called supermesh. A supermesh is defined as when a current source connected between two meshes. It is called supermesh. Now for the circuit shown below, determine the node. This problem is asked for previous exam. For this network shown below, determine the node voltage V1 and V2. It is very simple. Node 1 and node 2 forming a supernode. Node 1 and node 2 forming a supernode because the ideal voltage source 10 at an angle of 45 degrees is connected. Now apply KCL at node 1. Node 1, if you apply KCL, incoming currents equal to outgoing currents. All this assume that incoming currents 3 at an angle of 0 degrees incoming current. Outgoing currents are this one V1 minus 0 by J3. This one is capacitor minus J3. J6 is inductor 12 ohm. What is the current flowing in this means V1 minus 0, this one ground potential 0, V1 minus 0 by minus J3 plus V2 minus 0 by J6, V2 minus 0 by J6 that equal plus V2 minus 0 by 12, V2 minus 0 by 12. Now do the solve this. V1 you will get some angle and V2 make it as equation 1. From this again we have to consider the ideal voltage source V1 equal to 10 at an angle of 45 plus V2, make it as equation number 2. Substitute equation number 2 in 1, you will get this method of solution for this. V2 you will get substitute V2 in equation 1, you will get V1. Now that node voltage we can calculate the current. How to calculate the KCL? We have to apply node voltage. Nodal analysis means find the node voltage means we have to apply KCL at this and this nodes. But super node problem, it is super node problem. Similarly, super mesh problem also we will solve. Substitute V2, then you will get V2, V1 and V2 values. Find the node voltage V1 and V2 for the circuit shown below. Same problem, values are changed. Next, voltage transfer function. What is voltage transfer function? Voltage will be given as input, output also will get some voltage. When you give 10 volts, you will get 5 volts or 10 volts or 15 volts. The voltage transfer function is defined as ratio of output voltage to input voltage. G of S equal to V0 by Vi, where Vi is the input voltage, V0 is the output voltage. This is the definition of voltage transfer function. How the voltage will be transferred from input to output? G of S equal to V0 by Vi. Find the voltage transfer function for the given network. This also given for previous exam. Find the voltage transfer function for the circuit given below. J20 ohm minus J15, 5 ohm, 10 ohm. The circuit is like this. It is V1 and V0. Vi, it is Vi or V0. V1, V2 also sometimes given. Let V1 is the node voltage. This one node voltage V1. Let V1 be the node voltage. Apply KCL at node 1. If you apply KCL at node 1, I assume that it is I1 and this one I2, this one I2, this one I3. Incoming currents equal to outgoing currents. I1 plus I2 plus I3 equal to 0. Our total currents at this meeting point junction V1 is equal to 0. Now I1 you can write V1 minus Vi by J20 ohm. I equal to V by R. By using Ohm's law we are writing that V by R or potential difference V1 minus Vi by R plus what is the current here? I2. I2 is V1 minus 0. This is ground potential. Remember this 0 volts. V1 minus 0 by 5 plus V1 minus 0 by 10 minus J5. This is 10 ohm and J5 are connected in series. 10 minus J5 is the impedance. Impedance we have to consider. Now solve these equations. Then make common V1. If you made common V1 you will get in terms of Vi, V1 equal to 5.003 at an angle of minus 2.05. If you solve this, send to this side Vi you are sending to this side. V1 all terms will become one side. After that solve this, you will get 5.003 minus 2.05 Vi. From the circuit V0 equal to I03R, I3 into R. From the circuit V0 equal to I3 current flowing in 10 ohm. V0 is the voltage across 10 ohm. I3 into R is known as V0. V0 is I3 into R. What is voltage across resistor is called V0. In this resistor R, what is the current I3? I3 into R gives V0. From that I3 is Vi minus by 10 minus J5 into R is 10 ohm. If you substitute this, you will get V0. Therefore, voltage transfer function V0 by Vi ratio is this one. Find the voltage transfer function for this. Same problem. Apply KCL at node 1. You can solve it. You can find the nodes also. Next, if L equal to C equal to L and C, express the reactance in terms of J and find impedance if R equal to 30 ohm. R equal to 30 ohm is given, L is given, C is given. Find capacitive reactance, inductive reactance. After that, Z equal to R plus JXL minus XC. Substitute all this 30 plus J into XL is J 3.14 minus XC minus J 2.65, 30 minus J. This is the total impedance. Find the current flowing through 2 ohm resistor for the circuit shown below by using mesh analysis. This type of problems mostly will come from unit 3 for another type. RLC circuit కాకుండా ఇట్లాంటి ప్రాబ్లమ్స్ కూడా ఇస్తుంటాడు. అంటే AC వోల్టేజ్ ఇచ్చేసి అన్ని ఇంపెడెన్సెస్ we have to find. Apply KVL means mesh analysis we have to apply. For this, total voltage drop equal to 0 or supply voltage equal to total voltage drop. That we have to apply. Find the nodes in description. If you have any doubt, you can ask me. That one. In the circuit shown below, determine the equivalent impedance. 5 ohm, 10 ohm are in series. 5 plus J10, 2 minus J4, 1 plus J3. 3 impedances are there. Z1, Z2, Z3. Now Z equivalent is these two are in parallel and this is series combination of that. Z equivalent we are calculating now. 5 plus J10, 4 plus this one, 2 minus J4 is parallel with 1 plus J3. 2 minus J4 is 1 parallel with this one. You can calculate Z equivalent. Next one, a series RL circuit has RL XL. It is connected to parallel to a capacitor. Voltage applied to across it. Draw the vector diagram and show find the current. 25 plus XL is given. Directly you can calculate impedance. 25 plus JXL. And this one is 0 minus J 100 microfarad. We have to find XC for that. 100 microfarad means 100 into 10 power minus 6. You will get 31.J. Z equivalent is R plus JXL. Z equivalent 2 is minus JXC. Therefore, both are in parallel. Total impedance is, when resistors are connected in parallel, similar formula, but Z will come. Z equivalent 1 into Z equivalent 2 by Z equivalent 1 plus Z equivalent 2. That formula you can use. The same phasor diagram we can represent. I equal to V by Z equivalent 1. I2 equal to V by Z equivalent 2. If you want total I equal to V by Z equivalent. V by Z equivalent. Z equivalent, how much we calculate? Z total is this one. This one. If you want total current I, you can use this. But what is the current flowing in this and this? You can use this formula. Similarly, another problem. And the impedance of a circuit is Z equal to 6 plus J8, another problem. And the applied voltage is V, some angle is given, 50 at an angle 45. Determine average and apparent powers for that. Z equal to 6 plus J8. 6 plus J8, from that impedance you can calculate 10 at an angle of 53. This gives, what is this? Theta or phi. Theta equal to 53.13. If you want for phase angle, this you can directly consider. Or theta equal to tan inverse XL by R. If C also there, XL minus XC by R. Here only R and L is there. XL by R, if you do, you can get same answer. Next, power factor cos theta equal to R by Z. R by Z also you can use. Or theta equal to cos of 53. Cos of 53 also same answer you will get 0.6. Average power is Vrms Irms is into cos power P average. P average is Vm Im by 2 cos theta. Next, reactive power is sin theta, Vi sin theta. Similarly, another problem for the net one, total power supplied by the source. Total power supplied by the source. Number of problems if you solve, then you will get easily. You can find the link in description. These are the so many solved problems. Again, 3 impedances Z1, Z2, Z3, like that. If they are connected, you can solve it. This is about unit 3.